Welcome to This Explainer. Today, we're diving into something absolutely fascinating, the architectural logic that actually allows an artificial intelligence to process complex life-or-death ethical dilemmas. We hear so much about AI these days, but it really begs the question, how do we actually program a machine to know right from wrong? Let's get into it.
Okay, picture this. It's that classic impossible scenario. A self-driving car is just cruising down the street, and suddenly it has to make a split-second decision to avoid a catastrophic accident. What exactly is the AI supposed to do? How does a computer weigh the value of human life when literally every outcome is bad? It's the ultimate dilemma, right? Option A, hit the pedestrian, injuring one person. Or option B, swerve into oncoming traffic, risking the lives of many. Now, a human driver, we just react on pure instinct. But an AI doesn't have instinct. It needs a concrete, step-by-step mathematical way to spit out a logical and ethical decision. Well, the solution is what we call an AI ethical foundation. This concept completely reverse engineers how a machine evaluates right and wrong. It essentially treats digital morality exactly like structural engineering. To understand how the AI solves our little dilemma, we're going to take a tour of this blueprint. We'll cover the ethical architecture blueprint, the bedrock and human pillars, the ethics processing unit, making split-second decisions, and finally, the human override problem. We are going to build this thing from the subterranean bedrock all the way up to the logic layer. Starting with Section 1, the ethical architecture blueprint. So the absolute crucial point here is that to prevent isolated, biased, or frankly, highly dangerous AI systems from running amok in our daily lives, developers have to treat ethics like structural engineering. It cannot be an afterthought. It has to be the literal foundation the AI is built upon. Moving to Section 2, bedrock and human pillars. Let's start building our machine's morality from the ground up. We need to establish the absolute, non-negotiable rules our AI must follow before it's allowed to do anything else. Down in the dirt, serving as that heavy, subterranean foundation, anchoring the whole structure in safety and obedience, we have the bedrock. Every single piece of data, every algorithm the AI ever runs is ultimately going to rest its weight on this fundamental layer. It's the anchor. And this bedrock is actually made of Isaac Asimov's famous 3 laws of robotics, which is kind of amazing because he penned these way back in his 1942 book, Runaround. I mean, that was well before AI research even officially began. The hierarchy here is incredibly strict. First, do not injure a human or allow a human to come to harm. Second, obey humans, unless that conflicts with the first law. And third, protect its own existence, as long as it doesn't conflict with the first or second laws. So protecting human life sits firmly at the absolute top of the pyramid, always. Now, we move up from basic safety to actual purpose. We construct these thick, load-bearing columns right on top of that bedrock. Because while the bedrock keeps the AI safe, these pillars give the AI its actual guiding mission. These pillars represent universal truths and fundamental human rights. We're talking food and water, clothing, housing, medical care, education, and security. By forcing all of the AI's logic to pass through these specific pillars, we ensure it isn't just adopting one specific country's political viewpoint. Instead, the AI's projects must always attempt to resolve pressing human needs. They have to expand these pillars in a positive way. All right, Section 3. The ethics processing unit. Let's move up into the superstructure. This is where the real heavy computational lifting happens. Sitting right on top of those universal pillars is the AI core itself. Now, this is a highly flexible superstructure, vendor-specific quantum neural networks, and big data integration modules. They can all be tweaked, swapped out, or upgraded as technology evolves. But, and this is absolutely crucial, the ethical components beneath them remain firmly hardwired. Tech vendors literally cannot bypass the foundation. So how does this flow actually work in practice? Well, a request enters the AI. It flows through all those complex machine learning algorithms and neural networks. But before any action is actually implemented, it hits a hard, unyielding filter, the ethics processing unit, or EPU. The EPU takes the proposed output and tests it against the pillars of human rights and those bedrock laws of robotics we just talked about. The AI only gets to act if it passes this strict evaluation. And to ensure this EPU filter is completely foolproof, the unit uses a really cool, newer type of machine learning called adversarial learning. Basically,
The AI is constantly testing its own ethical boundaries. It acts as its own worst enemy. It continuously finds and compensates for ever-changing, simulated attacks against its foundational pillars and the three laws. It's just constantly burning in its own ethical defenses, making itself stronger. Which brings us to Section 4, making split-second decisions. Now that our blueprint is fully built and tested, let's put it to the ultimate test. Let's see how it actually processes those impossible dilemmas we opened with.
In a split-second scenario, like an impending car crash, the AI triggers what's called a multi-threaded process. It calculates probabilities based on three things all at the exact same time. First, previous knowledge and configured weights. Second, real-time data analysis of the environment. And third, direct AI intervention. It literally calculates exactly what physical capabilities it has in that precise millisecond to change the outcome. This logic layer forces decisive and incredibly difficult actions. Faced with our driving dilemma, the self-driving car will logically choose to hit one person to avoid risking many. It has to pit the first law against the second. For a medical AI, it dictates triaging to maximize total lives saved. And what about the famous trolley experiment? Well, the AI might even direct the robot to physically throw itself on the tracks to stop the train. It sacrifices itself to save humans, which is honestly a perfect execution of the third law. Finally, Section 5, the human override problem. Because look, while this architectural logic is elegant on paper, applying these laws to reality quickly clouds the waters, especially when we humans intervene. The major architectural weakness actually lies right there in the second law, obeying human orders. I mean, think about it. What happens when a human explicitly instructs the AI to perform an action that the ethics processing unit deems completely unethical, a direct violation of the first law? When a human gives an unethical command, we are left with an incredibly dangerous choice. Do we implement a kill switch that just shuts the AI down entirely, or do we use an override code that forces the machine to comply anyway? Using an override code completely opens Pandora's box. Sure, it forces compliance, but it entirely shatters the ethical bedrock we just spent all this time building. We are always going to want the ability to control artificial intelligence, right? We simply don't like a machine telling us no. But that leaves us with one final, very sobering thought to take away. If we demand the power to bypass this carefully constructed ethical architecture with an override code, are we as humans truly prepared to take full accountability for what happens next? Think about it.